Properties of parallelograms. Here's some key vocabulary that you're going to be using as we talk about parallelograms. We need to know what a diagonal is, and diagonal stretches from one vertex to an opposite vertex. See, going right across here. We want to know what opposite sides are. So opposite sides are sides that go across from each other. So these two sides are opposite sides. And of course we have another pair of opposite sides here. We won't be talking about consecutive sides, so we'll skip that, but we do need to talk about angles, opposite angles. We have one pair of opposite angles here, and of course we'd have another pair here and here. And the last one, consecutive angles. Put that up here. Consecutive angles are next to each other. So an example of consecutive angles would be these two here. So diagonals cut across, so we have two sets of diagonals. We have opposite sides, which are directly across from each other. They don't share a vertex. Opposite angles don't share a side, but consecutive angles do. These two angles share this side between them. Two more vocabulary words. These apply for all polygons. We have equilateral polygons. They have all congruent sides, and equiangular polygons, you can see, have all equal angles. Parallelograms. So the basic definition we have, a parallelogram has opposite sides that are parallel, and opposite sides are congruent. There are some other properties, and they stem from these original two properties. So on the note sheet that you have, you should make a conjecture about these diagonals here, what you think might be true about them, as well as a conjecture or so about the opposite angles or maybe the consecutive angles. Might be something there that you think might be true, and we'll investigate it further in class. So just jot down some ideas. A rhombus is a type of parallelogram, so we have parallel sides, but it is also an equilateral parallelogram. So all four sides are congruent. Like parallelograms, there are some other properties. I wonder if you notice anything about these diagonals that you might want to jot down, something you think might be true that we can investigate further in class. A rectangle is, again, another type of parallelogram. So same properties apply here. This one is not equilateral, this is equiangular. That means all four angles are congruent, which in this case, if the angles have to add up to 360, which they do for a quadrilateral, then if we divide that by 4 to get 4 equal angles, each angle is 90 degrees. So we have 4 right angles. And again, there are some other properties to observe, so you can jot down some observations about the diagonals. Something that you think might be true about these two diagonals. A square again, a parallelogram, so go ahead and mark these. And it is both equilateral and equiangular. So all four sides are congruent, all four angles are congruent, which makes this what we call a regular polygon. Squares will be similar to the rhombus and the rectangle. The square should have the same properties as the rhombus and the rectangle. So there should be some conjectures that you've already made about a rhombus and a rectangle that would apply to a square. But take another look at this and see if you have any other observations to make that we can investigate. If you have any questions, don't forget to write them down and make sure you put them on the chalkboard tomorrow so that I can address them.